Okay, so now that we've looked at some of the basics of percents, let's look at the simple calculations and then start applying them into word problems. So something simple like blank is 60% of 80. When we solve a percent problem, I always start with the percent. So 60%. Of course, that is 60 out of 100. And just like we did with the fractions, to turn a fraction into a percent, we're going to go with that proportion. So on the other side of the proportion over here, we have to figure out what number matches up with the 60 and what number matches up with 100%. Now remember, 100% represents the whole thing, or the starting amount. So now up in the problem, there are two other numbers. There's the 80, but there's also the missing number, the one we're looking for. Which one of those matches up with the 60%? Well, blank is 60%. So that missing number matches up with the 60%. So that blank goes here. So that means the 80 has to go on bottom. Think of this of 80 as out of 80, which implies that that has to be on bottom. And then, of course, we solve. 60 times 80 is 4,800. Divided by 100 is 48. So 48 is 60% of 80. Those can be worded in a lot of different ways. I'm just going to show you one other way it can be worded. 30% of 120 is blank. This is actually the exact same type of question, just worded way differently. As always, I'm going to start with the percent. 30% is 30 out of 100. Now we have the 120 and the missing number. Which one matches up with the 30%? Well, again, you see of 120, you think of out of 120, which implies that has to go on bottom. So the missing number goes with the 30. And again, we cross multiply and divide. 30 times 120 is 3,600. Divided by 100 is 36. Other types of problems. 42 is blank percent of 60. Well, we said we always start with the percent, but in this one, the percent is missing. Well, that doesn't change anything. It's still blank out of 100. Now, on the other side, we have to match it up. 42 is blank percent, so the 42 matches up with the missing number. And of 60, think of out of 60 again, that implies that goes on bottom. So you can see we're missing a different number in the proportion, but it's still going to be cross multiply and divide. 100 times 42 is 4,200. Divided by 60 is 70. 42 is 70% of 60. So here, blank percent of 80 is 104. So again, we're missing the percent, but it doesn't matter. We're just going to start out as blank over 100. Now we have the 80 and the 104. Which one goes on top?
80.
Careful. Of 80 implies out of 80, so that goes on bottom. Blank percent is 104, implies that the 104 goes to the blank. It's reflex to want to put the bigger number on bottom, but you have to be careful. Since the bigger number's on top, what does that tell us about our percent? It's bigger than 100%. So we're going to cross multiply. 100 times 104 is 10,400. Divided by 80 is 130. So 130% of 80 is 104.
Whenever we do these sums, I always make
Okay, that is one shortcut that is very commonly taught. Is over of. Is 104 goes on top, of 80 goes on bottom. That works for these generic little sentences like this, but when you get into word problems, that can confuse you, so you have to be careful with that. Oh, let's have 36 is 60% of blank. So here we have the percent this time, so 60% is 60 out of 100. 36 goes on top or bottom? Top. 36 is 60% out of blank, so the blank goes on bottom. So we cross multiply and divide. 100 times 36 is 3,600. Divided by 60 is 60. 36 is 60% of 60. Or we could have 30% of blank is 27. How do we start this one? 30 over 100, good. Equals 27 over blank, good. Then we will cross multiply. So what do we multiply? 100 times 27 is 2,700, and then divide by 30 gives us 90. Now, there is something that is often taught called the rate method of percents. It's what I was taught in elementary school and what a lot of people are still taught. In the rate method, you turn your percent into a decimal and you go from there. So for this problem, they say 60% is 0.6. You would do 80 times 0.6 gives you 48. Well, that gives you the answer, and it's really quick and easy. But there's a problem with that method that I don't like. If that's the way you were taught and that's how you know how to do it, feel free to use it. But if you're not good at it, where there's a lot of mistakes made, there you turn the percent into a decimal and you multiply it by that decimal. But if we come down here, 60% is 0.6, but it's not going to be 36 times 0.6, it would be 36 divided by 0.6. So if you use that rate method, you have to not only move the decimal point to make it a decimal, then you have to figure out, do I multiply or do I divide or what do I do? Again, if you were taught that way, feel free to use it. That's the way I do it because it's a little quicker for me. But it also leaves a lot of confusion. With the proportion, all you have to do is get the numbers in there in the right place, and the calculation is always cross, multiply, and divide. Let's have you try a couple. Find the number that goes in there. 16, perfect. How about this one? No. When they do the examples, they might show you one way or another, but you can do it whatever way you have to. So this one's going to come out to be 60. Good. And finally, $56 is blank percent of 80. What did we come up with? 70. Perfect. Anybody have any problems with those? The first one you did? You got it figured out? So 20% is 20 over 100 equals blank over 80. 20 times 80 divided by 100. You divided by 80. You should divide it by 100. Yeah.
I got it.
Okay. Now there's something the book uses. It uses a mnemonic device. Of course, you have the rate, which we talked about, which is the percent turned into a decimal. The portion and the base. The base is whatever represents the 100%. The portion is the piece that we get. So in a problem like this would be the portion. Of course, the rate would be 0.7, and the base would be 80, the whole amount. Now, again, I'm not going to force you to do it any particular way. This is just how the book does it, just so you understand its little thing that it uses. The book uses a little thing like this. So I think I get this right. I don't remember how it did it anymore. I don't use it very often because I don't like it. Yeah. Base times rate over portion. Is that right? No, it's the other way around. Let me try that again. You can tell how well I like it. The portion over the rate times base. So it uses this little thing divided into 3 spots. And what they tell you to do is if you're trying to find the portion, you cover this up, take the rate times the base. If you're trying to find the base, you cover this up, it's the portion divided by the rate. Well, I don't like those little gimmicks because it's just something I should remember. Obviously, you can see I have a hard time remembering it because I don't use it. I will never force you to use it. It's something in the book. If it's something you like and you want to use, talk to me and I'll show you more about it. But I'm not going to waste class time on it because I think it doesn't work for me and I don't think it's a very useful tool. I know it has been taught in other classes before, so if it's something you like and you want to make sure you know how to use it, let me know. So anyway, now that we have some of those basic percents, let's look at how it gets used. For example, let's say that IUB Corp has a projected profit of $80,000 for the month. Profits are projected as 15% of gross sales. What were the gross sales? Okay, so just like any of the other problems, when we run into a word problem, we start out with the percent. So we have 15%, which is 15 over 100. What does the 15% represent? Well, there's 2 items in here. There are profits and there are gross sales. Does the 15% represent the gross sales or the profits? Careful. 15% of the gross sales mean out of the gross sales. So the 15% does not represent the gross sales. It is taking something out of them. So the 15% represents the profits. Profits are 15%. So that is the profits, which means the gross sales must match up with the 100. This is why I love using the proportion in word problems, because now I know where the numbers have to go on the other side here. Since the 15 represents profits, whatever goes over here better represent profits. The 100 represents gross sales. Whatever goes over here has to represent gross sales. Well, what other number do we have in this problem? 80,000. Does that represent gross sales or profits? Profits. So it's going to go here. So now we're going to cross multiply and divide. 100 divided by 80,000 and then divided by 15 is, what is it? 100 times 80,000 and divided by 15. $533,333.33? Yes. Okay. Joy receives a raise from $35,000 to $38,000 per year. What percent is her raise? So in this case, we are looking for the percent. So it's blank over 100. Now there's two things that are represented here. One of them is a raise. Let's start out with that. Does a raise represent the 100% or does it represent the missing percent?
Missing.
Yeah. What percent is her raise? So that is the raise. Finding what represents the 100% is a little trickier here. Remember, we said the 100% is usually either the whole amount or the starting amount. In this case, both of them are really the whole amount. You know, the $35,000 is the whole amount of what she got paid last year. $38,000 is the whole amount of what she's going to get paid next year. So the whole amount doesn't apply. So in this case, the 100% must represent the starting amount, which is the $35,000. Does the $38,000 go on top then? Does the $38,000 represent a raise? It represents her new salary after the raise. The raise is $3,000. Where did that come from? We had to subtract to get that number. So sometimes in these word problems, the number we're looking for isn't given. It has to be calculated from the other numbers that are. So then 100 times 30 divided by 35 is should be 8.5. 8.5714286 approximately. 8.57. What it'll tell you to round to the nearest hundredth of a percent or tenth of a percent or whatever. It might. 8% raise would be a great raise. I haven't had more than like a 2.5% raise in years.
I was going to ask you that. How, say you're going to get a raise in 1% of your current salary.
I have had as big as like a 3.2 or 3.8% raise before, but typically my raises have been like 0.8 to 1.5%, somewhere in there. Unless you like quit a job, and usually to get the big raise, you got to leave a job and go somewhere else. That's when you get the big raise.
Can you do that off of base salary? Like
Yeah, that'd be the same way. Yeah. Whatever your base salary is, then the difference between your salaries, that's going to be the percent of your
how do you
raise.
know, like you say you don't know your ending salary.
Oh, then I wouldn't leave jobs if I didn't know what my ending salary was.
Oh,
gonna
no,
be.
your current
Yeah.
salary.
Yeah.
I'm trying to figure out what your 1.something% is good.
Oh, okay. Let's say that's a good question. Let's say your current salary is $32,000. You're going to get a raise of 1.8%. This actually ties into one of the next things we're going to do, so let's use it. What that means is the new salary is going to be 1.8% more. So 1.8% is 1.8 out of 100. Where's the 32 going to go? 32,000 goes on bottom because it is the initial amount, the base amount. The 1.8 represents the amount of the raise. That's what we're looking for. So we're going to do 1.8 times 32,000 divided by 100, which is going to give us $576. Now that's not our answer. That's the amount of our raise. We wanted to know how much we're going to get paid. So we're going to take 32,000 plus $576 to get 32,576 is our new salary. This type of problem is actually what we were going to look at next anyway. It's called a percent increase problem. We started with a value and we want to increase it by a certain percent. So for here, what we had was our starting salary We added our raise to that to get our new salary or ending salary. And we have the dollar amounts there that represent all of those numbers. But in this type of problem, there's also percents that represent each of those numbers. The starting salary, of course, we said was 100%. The amount of the raise was 1.8%. What that means is the ending salary, 100 plus 108, is 101.8% of the starting salary. So what we could have done there, rather than finding 1.8% and adding it on here, we could have just said, hey, a 1.8% means we're making 101.8% of what we did before. And we could find 101.8% of 32,000, which will give us 32,576. So it saves us that step of having to add it back on. In fact, this little table I made up here is actually quite a useful tool. We'll actually use that in some of these problems. I use it a lot in these problems, and I'll show you why. For example, we could use it in finding the amount of the increase. Let's say that a price increased from $2.12 per pound to $2.38 per pound. Find the percent increase. This is similar to that salary problem where the salary went from $35,000 to $38,000. Here, let's look at the starting amount. To it, we're going to add an increase. Then we're going to get the ending amount. And I'm going to use that little table. Writing it out in words often helps. It doesn't matter what words you use. You could have before plus increase equals after, or whatever words make sense to you. They don't have to be the same as mine. But each of these items is going to be described by a percent and again by a dollar amount in this problem. So let's fill in. $2.12 will go where? Starting dollar amount. $2.38, ending dollar amount. It looks like that's all the information we have, but there's one more information we always have. When we're dealing with a percent, there's always something that represents 100%. And that is generally the starting amount or the base amount. So on the percent side, we have 100% there. That is all the given information, but we do have some information that we can calculate rather quickly. Mainly this right here. How can I find that number? Perfect. We subtract 238 minus 212 is 0.26. That is the dollar amount of the increase. What we're looking for is the percent of the increase, which is this number right here. So now in this table, there are two lines that we need. We need the line that has the information we're looking for, which is this line right here. We're looking for that percent of the increase. We must have the number on the other side, which we do, the dollar amount. And then there needs to be one of the other lines that has both amounts. This bottom line does not. It's missing the percent, so we don't need that one. The top line has both the percent and the dollar amount, so that's the one we're going to use. So we can either pull those numbers out and make a proportion, or we can just cross multiply and divide right in the table. 100 times 0.26 divided by, no, there's a proportion right there. 100 times 0.26 divided by 212 gives us 12.26%. Any questions? Does that make sense? What's that?
Nothing.
Yeah, 12.26415. Yeah. Now you might be looking at that saying, I could have figured that out. I could have just subtracted the numbers, and then a blank over 100 equals the 26 cents over the $2.12. Yes, you could have figured that out. But there are some problems where doing it like that is very, very difficult. Let me show you. After an 8% price increase, airline ticket is $450. Find the original price before the increase. I'm going to pause this. I'm going to let you guys try this one on your own. Let's see what you're coming up with here. What did you guys get for answers? How many of you got 414? Okay. That's the answer I expected, but it isn't right. Let me show you why. The 8% does not come out of the 450. Most people would jump to find 8% of 450 and subtract it. Problem is, the 8% came off of the original price, not the new price. So the original price plus the increase gave us the new price. And we have dollars and percents again. We know the new price is $450. We know the amount of not the amount, but the percent of the increase is 8%. And we also know 100% goes in the original price. From here, we've got 100 plus 8 makes 108. So this new price is 108%. What number are we looking for? What the original price is. We're looking for this one here. So that tells us we need this top line. What other line do we need? The one that has both numbers in it, right? So this one. So it's that middle line that we do not need in this case. So I'm just going to cross it off. We don't use it. And we can cross multiply and divide here. 100 times 450 divided by 108. 416.67. Very good. So $2.67 more. So again, it's only $2.67, but over time that can make a big difference. Remember that 8% came off of the original price, not of the new price. Let's try another one. After a 12% increase, you pay $8.50 for a product. What was the old price? I'll pause it and I'll... Okay, so we have old price plus increase equals new price for cents and dollars. What goes in our table? 100% for the old, 12% there. What else? 850 is the new, 112 here. We're looking for the old price, so we don't need the middle row. 100 times 850 divided by 112. Okay, my calculator's not working. There we go. $7.59, you said? That's it, $7.59. Perfect. You guys feeling better about those? Okay. The other side of that coin, something you see all the time is 40% discount or 40% markdown, 40% off, however you want to word it. So let's say you have something that's marked as a 40% discount, and the sticker price, of course, before the discount is $28. That's before the discount. That's the list price or the original price. What is the new price? Well, again, just like before, we can find 40%. 40 out of 100 equals blank out of 28. And we can cross multiply and divide. 40 times 28 divided by 100 will give us $11.20, yes. But that's the amount of the discount. We want to know what the new price is after the discount. So it'd be 28 minus $11.20, which would be $16.80. But this is just like before. We had the original price. This time it's minus a discount instead of plus an increase. This is the new price. On the other side over here, we could have our percents. 40% is our discount. The original price, of course, is 100%. 100 minus 40 is 60%. So what we could have done when we saw this problem is a 40% discount means we're still going to pay 60%. That's something called a complement, by the way. If you start out with 100% and you take a certain percent away, what's left over is its complement. When we get into the next unit on merchandising, we're going to use that a lot. So anyway, instead of finding 40%, we could have found 60% of 28. And when we cross multiplied and divided, we would have came up with $16.80 as the new price after the discount. So let's say something has an old price of $70 and a new price after a discount of $28. Find the percent off or the percent discount. Oh, we could probably figure this out using conventional methods, but I like to use my table. We've got the old price minus a discount gives us the new price. Percent and dollars again. We know, well, on the percent, it looks like we know nothing, but we do know the old price is 100%. On the other side, the old price and the dollar amount of the old price is 70. Where's the 28 go? The new price. And of course, we can very quickly find this number right here by subtracting. 70 minus 28 is 42. What number are we looking for over here? The discount or the new price? The discount, the percent discount. So we don't need the bottom row. It will be 100 times 42 divided by 70, which is 60% discount. After a 30% discount. An item costs $24.50. Find the original price. So let's see if you can translate the last examples into this, and I'll have you guys try to find that quick. So what do we get here? Well, 30%, so 30 goes in for the discount. 100 goes in for the old price. Where's the $24.50 go? New price. And of course, we can very quickly find 100 minus 30 is 70% for the new price. And we are looking for the original price or the old price. Don't need the middle row. 100 times $24.50 divided by 70 is 35 bucks. How many of you got 35? How many are feeling pretty good about these?
I just have a question. Do you always subtract to get the new?
If it's a discount, you subtract. If it's a markup or an increase, you add.
Okay, so you should always have something in that
Yes.
ending.
Yep.
That's where I scribbled. I like.
Yeah. In any column, if you have two numbers, you should be able to find the third. Yeah. Question?
Okay, it might be lame, but how do you know to put the 100 on top?
Okay. The 100 always goes with the original price. So whatever you started at is always 100. Whether it's an increase or a decrease, the starting amount was always 100%. Now, when we get into the next unit, there are going to be cases where the 100 goes somewhere else. We start doing about markups. But that's when you start talking about what is the markup based off of. Is it based on the cost? Is it based on the selling price? And other things. The 100 is technically always the base, but when you're dealing with an increase or decrease, the base is always the starting amount. Any other questions? Okay, that is it for the new material. I'm going to end the recording here, but I'm going to remind you, of course, quiz 2 is due tomorrow, which is Wednesday at 11:59 p.m. Homework 3 is due next Tuesday. And of course, Unit 1 test is in class next week. If there's anybody who needs a private room or anything like that, let me know and I'll make sure it's arranged. In the evening classes like this, I have to go down and make special arrangements because a lot of times they're closed down there, so I have to make sure they stay open for us. Or if you need anything else like that, let me know. Otherwise, I'll be sending that out probably in the next couple days, so it's at your locations. So that you can, that is all we're doing next week is the test. Now, I am going to do a quick review of the test if anybody wants to stay.